So this video is on semester 2, RFF number 3, which is the review for the final exam, the one with the pineapple on it. Okay, on number 1, we're trying to add these two rational expressions. We need a common denominator. First thing we want to do is look and see, can I do anything with this? Can I factor that? And I cannot. So what I'm going to do is I am going to try to get a common denominator. And so that common denominator is going to be a 2x plus 5 times an x minus 7. So I will be multiplying this fraction by x minus 7 on top and bottom to get that common denominator, which means when I multiply the top by that, I get an x minus 7. And then when I do it with this minus, don't forget the minus, and I take this side, I'm going to multiply this by the 2x plus 5, top and bottom. And so I'm going to think of this as a negative 5 distributing in. So that means it's going to be a negative 10x and a negative 25. So I'm going to combine like terms, and I'm going to get a negative 9x minus 32 over 2x plus 5 times x minus 7. And that's our answer. On number 2, on this one, I'm trying to find for all x the solution to this. So it's going to be 2 sine x equals 1. So sine x equals 1/2. And so I need to figure out where my sine, which is my y coordinate, is going to be a 1/2. So that is going to be at long comma short, which is pi 6. And on the other side over here, long comma short, which is going to be 5 pi 6. Now, do check to make sure we can't write one in terms of the other. So going from here to here, you can see that that distance is less than pi, which it would be half a circle, and this is more than it. So I can't add something to pi 6 to get to 5 pi 6, and then to 5 pi 6 to get back. So we're going to have two sets of answers here. One is going to be pi 6 plus or minus 2 pi n. The other is going to be 5 pi 6 plus or minus 2 pi n. And those are our answers. On number 3, this one is another one like this, but I have a sine squared, a sine x, and then a constant. This one I'm going to factor, okay? And because I have a sine x in front, I know I'm going to have a sine x times a sine x. And then to get this minus 2 part of it, it's going to be a positive and a negative 2 and 1. And I'm thinking a plus 2 and a minus 1, because this would give me a positive 2 sine x, and this would give me a negative sine x, which gives me the sine x I need right here in the middle. Okay. So this is going to equal 0. And so I'm going to get two different situations here. This first one would be sine x is equal to negative 2. And that's impossible. That's undefined, because sine is between 1 and negative 1. If you think about on the unit circle, the maximum it'll be is 1, the minimum is negative 1. So that's not going to give me an answer. No. Then the other one is going to be sine x equals 1. And I need to pay attention to this is only between 0 and 2 pi, including 0 and including 2 pi. And sine is 1 up here at pi halves. And that's the only spot, and that's going to be our answer. On 4, we're trying to simplify this. So what I do know is that 1 plus cotangent squared x is equal to cosecant squared x. It's one of those triples, Pythagorean identities, I should say. And so if I was to keep my cotangent squared x here, and I was to minus my cosecant squared x from both sides, and then I would take the 1 to the other side, the answer to this is -1. On the next one, again, we're going to clean this up. So I'm thinking I'm going to write everything in terms of sines and cosines. So tangent x, here, I'm going to color code. So this is tangent x, and that's going to be sine x over cosine x times. And my secant x, the reciprocal of secant is cosine. So this is going to be 1 over cosine x. And then this 1 minus sine squared x, let me just jot this over here in orange, that sine squared x plus cosine squared x equals 1, which means that if I was to keep the cosine squared x on this side and I go 1 minus sine squared x, those would be the same. So this 1 minus sine squared x is really a cosine squared x. So what's going to happen is I have a cosine x and a cosine x, which is a cosine squared x. That's going to cancel with this cosine squared x. And my final answer is going to be sine x. On number 6. So on this one, I am trying to figure out where my cosine is a negative root 2 halves, and I'm going from 0 to 2 pi, including 0, including 2 pi. So cosine is negative in quadrants 2 and 3, and it is at the pi force where I have root 2 halves comma root 2 halves, okay? So on this side, this is going to be negative root 2 halves, positive root 2 halves. So this is going to be 3 pi fourths. That's one answer. And then again, down here, this was a negative root 2 halves and a negative root 2 halves, which is a 5 pi fourths. And so those are our two answers from 0 to 2 pi, 3 pi fourths and 5 pi fourths. On number 7, we're going to factor. You can do box to diamond. What I'm going to do is I am going to, so this is this one right here, is what I'm working on. I know I'm going to have a 3x and an x because of the front. Now the back, that negative 8 is either going to be an 8 and a 1 or a 4 and a 2. And I got to figure out the order. I'm thinking I'm going to put the 4 here and the 2 here, because this would give me a 6, this would give me a 4. If I subtract that, that's a 2, but I want a negative 2. So that means I want this one to be negative and this one to be positive. But again, you can do a box to diamond if you prefer. Over, and let's take a look at this bottom one here, okay? So I'm going to have a 2x and an x because of the 2x squared. And then the 10 is going to be a 10 and a 1 or a 5 and a 2. I'm thinking 5 here, 2 here, It's a positive 10, but I'm not going to have pluses here. I'm going to have minuses here. This would give me a -4. This would give me a -5, and that gets me the -9. So at this point, I do see some things I can cancel, but let me just finish doing this problem. So over here, this 4x squared minus 25 is a difference of two squares. You want to be able to recognize that. It's a square minus a square. The square root of 4x squared is 2x. So I'm going to have a 2x in front of both. The square root of 25 is 5. One's going to be a positive 5. One's going to be a -5. So I would have gotten a positive 10x, and the negative 10x would have canceled. And that's why I don't have an x. And then on the bottom, for this one, let me just kind of first start here. Looks like I factor a 6 out of this, and I get an x squared minus 4. So I'm going to have a 6, and then that x squared minus 4 is another difference of two squares, x plus 2, x minus 2. Now, restrictions. So restrictions, can't have things make my denominator 0. So in terms of restrictions, x cannot be 5/2, 2, -2. Those are going to be my restrictions, okay? Because I cannot have 0 in my denominator. And then looking at this, I have some things I can cancel. Here, this x minus 2 and this x minus 2. Over here, I have a 2x minus 5 and a 2x minus 5. And that looks like that's it. So my final answer is going to be 3x plus 4 times 2x plus 5 over 6 times x plus 2 times x minus 2. And that's your answer. On 8, this one is one that I want to rewrite. Instead of times dividing by a fraction, I'm going to multiply by the reciprocal, okay? So if I rewrite this, I'm going to have 35x squared over 4y times the reciprocal, and that would be 8y to the 5th over 28x to the 7th, y to the 2nd. Now, in terms of any restrictions here, I need to give restrictions on my denominators at any point denominator. So I am going to have y cannot be 0 from the original setup. Now that I flipped it, I also am going to have x cannot be 0 because that would give me a 0 also in the bottom. And now I'm going to do a little simplifying in terms of my numbers. So 4 goes into 8 twice. And let's see. My 35 and my 28, I can take a 7 from both of them. So this is going to be a 5. And this is going to be a 4. And then I can take 2 from here, so that's gone, and 2 from here, so I get a 2. So in terms of the numbers, I'm going to have a 5 on top and a 2 on bottom. And then let me kind of just clean up the x's and the y's, and I'm going to simplify. So on top right now, I'm going to have an x squared y to the 5th. On bottom, I'm going to have an x to the 7th, and then a y and a y squared is a y to the 3rd. Now, I can clean this up. My x to the 2nd over x to the 7th, 2 of them can cross off from top and bottom, leaving me with 5 on bottom. My y to the 5th over y to the 3rd, 3 of the y's can cancel, leaving me with 2 on top, and that's my answer. On number 9, I want the 4th term. So this is the binomial theorem. So what I do for this is I'm going to take the power, minus the term I'm looking for, which is the fourth term, and I always go +1. And when I do that, I end up getting 3 plus 1, which is 4. So it's not 4 because of the fourth term. It just happens to be 7 minus 4 is 3, and 3 plus 1 is 4. So I'm going to be using this 4 and the 7. So when I'm doing this using combinations, I'm going to go 7 because of the 7, that is the power that I'm raising this thing to. Choose 4 because of this 4 here when I did that math. And then I am going to take my 5x and raise it to that fourth power. And then I'm going to take my 2y to the third, and I'm going to raise it to the difference between 7 and 4, which is 3. And then I'm going to put this in my calculator. So let me just do bits of this. So let me do 7, choose 4, and 7 choose 4 is 35. And then 5 to the fourth is going to be 625x to the fourth. And then 2 to the third is 8. Y to the third, raise the third, power to power, I multiply. And then I'm going to take 625 times 35 times 8. I end up getting 175,000 x to the fourth, y to the ninth. And that's my answer. Okay, on number 10, again, this is one I'm going to factor. This is going to be just from 0 to 2 pi. So because I have a 2 cosine x squared in the front, I'm going to have a 2 cosine x and a cosine x. I'm trying to get a -3 in the back. So that's either a +3 and a -1, or a -1 and a +3. And I'm trying to get a -5. So I'm thinking -3 because this will get me a -6, +1 because this will get me a 1. And that will get me my -5. Okay, so now this is equal to 0. Okay, so I'm going to be working out these two things. So here, I'm going to get 2 cosine x equals -1. So cosine x equals a -1/2. Okay, so let's see all of those values from 0 to 2 pi. So cosine is your x. I want a -x, so it's going to be quadrants 2 and 3. So I'm going to go short, long, which is here. And that's going to be 2 pi thirds. And it's also going to be down here, because that is also short and then going down long. And that is going to be 4 pi thirds. So those are 2 answers. And then for the second piece, set this equal to 0, and I get cosine x is equal to 3. And cosine and sine, the max and min that they can ever be is 1 and -1. So it's never going to equal 3. So my 2 answers are 2 pi thirds and 4 pi thirds. 11, we want a factor expression and use fundamental identities to simplify. So what I notice here is there's a sine x and a sine x. So I'm going to take out a sine x. And I'm going to get cotangent x squared plus 1. And remember the formula, the Pythagorean identity, that cotangent squared x plus 1 is equal to cosecant squared x. So I'm going to put that in place of this right here. So I am going to get sine x times cosecant x, and sine x is sine x, and cosecant squared x is going to be 1 over sine squared x. So what's going to happen is I am going to have a sine x over sine squared x. So I can have a sine x cancel from top and bottom. So I'm going to get 1 over sine x. And the reciprocal of sine is cosecant. So this is going to be cosecant x. And that's your answer. On number 12, just solving a quadratic. So let me get everything on one side, 0 on the other. So 2x squared minus 6x minus 3 equals 0. Not thinking that that's going to be able to multiply to a -6 and add to a -6, because I'll have a 6 and 1 or a 3 and 2. So I think I'm going to have to use quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to, and -b means make your b opposite. So it was a -6, now it's going to be a +6. Plus or minus the square root of -6 squared. Notice I put in parentheses, because that should end up being a +36. If you're putting it in your calculator, minus 4 times my a, which is 2, and my c, which is -3, all over 2 times my a, which is 2. So this is going to be 6 plus or minus, and then I'm going to do the math underneath my square root. So I'm putting it in my calculator. Basically 36 minus 4 times 2 times a -3. I got a 60 over 4. Now, 60 is not a perfect square, but there is a square in 60. 60 is a √4 times a √15. So that's going to be a 2√15. So this is going to clean up to 6 plus or minus 2√15 over 4. Now, everything's divisible by 2. This is going to be a 3 plus or minus √15 over 2, and that's my 2 answers. (13), this is one that I am going to rewrite in. So there's 2 ways you can do it. You can log both sides. I'll do it 2 ways. You can log both sides, and when I take log of 3 to the 2x plus 1 equal log of 7, a log of something to a power, the power moves in front. And so I'm going to get a 2x plus 1, and I'm going to move this line here for a second. Log 3 equals log 7. I'm going to divide by log 3, so I'm going to get 2x plus 1 equals log 7 over log 3. I'm going to put that into my calculator. And I'm going to just write it as an approximation here, but I'm going to keep it in my calculator. So log 7 divided by log 3 is about a 1.77. Again, I'm keeping it accurate in my calculator. I'm going to minus 1 from both sides. So it's going to be about a 0.77. Then I'm going to divide by 2. And when I divide by 2, I get about a point, let's say 39 as my answer. A second way to do this same problem is to rewrite it in logarithmic form. So you're going to go log base 3 of 7 because it equals 2x plus 1, because what your log equals is always the power. And this log base 3 of 7, you can put that into your calculator. Okay, I would do this under, I would do alpha window, and then number 5, okay? So alpha, window, and then number 5, I can put that log base 3 of 7 in my calculator. So I'm putting in my calculator and I end up getting a 1.77 about, okay, again, keeping it in my calculator, equals 2x plus 1. You can see I have the same exact thing here. So I'm going to minus 1. I'm going to divide by 2. And in both cases, I get the same answer. So 1, I'm logging both sides. 1, I'm rewriting in logarithmic form. On 14, this is sum and difference of 2 cubes. This one is a sum, and I'm just going to write the formula. So a cubed plus b cubed is equal to, take the cube root of a cubed, which is a, plus take the cube root of b cubed, which is b. And then at this point, take this first term, square it. Then you're going to change the sign. Always going to be opposite sign from what is here or here. Then you're going to multiply these together, which is an AB. Don't double it like we do for a perfect square. It is just AB. And then you're going to square your last term. And that is also going to be a plus no matter what that sign was, because when you square anything, you get a positive. And that's going to be a B squared. Okay, and that's the formula. So I am going to take the cube root of 27 x cubed, which is 3x. I'm going to take the cube root of 64, which is 4. Now I'm going to square this, which is going to be a 9x squared. I'm going to change the sign, so it's going to be a minus now. I am going to multiply these two things together. So when I multiply these together, I get a 12x. The sign was already determined because since that was a positive, this one's going to be a negative. And then we're going to square our last term, and that's going to be a plus 16. And that's our answer. On 15, we're going to calculate this. We're dividing. And so whatever this is, whatever makes it 0, I'm going to use synthetic division, put it in the box right here, -4. And then I'm going to look at my coefficients, and I'm going to make sure that I put them in descending order. And if anything's missing, I put a 0. So I have 3 for my x to the 5th, put 0 because I don't have an x to the 4th, a -5 for my x cubed, a 2 for my x squared, a 0 for my x, and then a -12. And then I am going to bring this down, which is 3. And now I'm going to take 3 times -4, which is -12, combine, -12. -12 times -4, which is 48. Let me just double check all my numbers. Okay. So, that's was a -12. So I get a -12, I get a 48. So I end up getting a 43. Okay, 43 times a -4 is a -172, which is a -170. I'm going to take that -170 times a -4, which is a 680. So I get 680 times a -4, which is a negative, big numbers here, -2,720. And I add that, and I get a -2,700 and 32. Now we're going to write this out. We're going to get, since it started with an x to the 5th originally, this is always what I call a depressed polynomial, 1 degree less. So 3x to the 4th minus 12x to the 3rd plus 43x squared minus 170x plus 680. And then that negative 2,732 is the remainder. So that's going to be minus 2,732 out of or over x plus 4. And this is your answer. This is what you get. That negative 2,732 is the remainder, but this is your answer when you are doing that division. Okay, on number 16, if you want to find the zeros, that means we basically want to know what the x-intercepts are. So it's really set equal to 0 and we're solving. So I can factor out an x squared from both of these and I get an x squared minus 25. And then this x squared minus 25 is a difference of two squares. Again, it's very important to understand differences of two squares. So this is going to be an x plus 5 and an x minus 5. So my answers are going to be, this is going to be x equals 0, and this is really a double root. We have that twice. This is going to give me x equals negative 5, and this is going to give me x equals 5. So if it's a degree 4, you should get 4 answers. It looks like we have 3, but this one again is a double because it's an x and an x. So you really have 0 twice, but you only need to list it once. And those are your zeros. On 17, determine if x plus 2 and x minus 4 are factors of the function. So what we're going to do is I'm going to take this x plus 2, negative 2 makes that 0. I'm going to do synthetic division. 1, negative 3, negative 4, 12, making sure it's in descending order and I'm not missing anything. Bring down this 1 times negative 2 is negative 2. I get a negative 5. Negative 5 times negative 2 is 10. I get a 6. Negative 12. 6 times negative 2 is negative 12. Negative 12 and positive 12 is a 0. So because I got a 0, okay, it means it is a factor. So the x plus 2 is a factor. So now let's try the other one, which is the negative 4. So what makes negative 4 0 is positive 4. So I'm going to do 4. Or I can just factor this too. But I'll show it both ways. So this is an x squared minus 5x plus 6. When I factor that, that's going to be an x minus 3, x minus 2. So this is not going to be a factor, but I will show it also here. Here, let me do it in a different color so it doesn't get confusing with that. Okay, so I'll do it in orange. So now I'm going to do the x minus 4. So I'm going to put a 4 here. 1, negative 3, negative 4, and 12. And you'll see that I should get not 0 this time because you see that that was not one of those factors. So this is a 1. Bring it down. 1 times 4 is 4. I get 1. 1 times 4 is 4. I get 0. 0 times 4 is 0. I add, I get 12. Not a factor. So x plus 2 is a factor. X minus 4 is not a factor. Okay, 18, we're going to be adding these fractions. This right here is going to be an x plus 3 squared, or an x plus 3x plus 3 is how I will write it. This other one over here is going to be an x plus 3 and an x minus 3. So I need to get a common denominator. And my common denominator is going to consist of, I need everything from the first fraction denominator, which is an x plus 3 and an x plus 3. I need it twice because I have it twice in that denominator. Then from the other denominator, I need an x plus 3, but I already have one. I have 2 of them, but I have one at least. So then I'm going to be looking for this, and I don't have that, so I need to add that. So that's going to be my common denominator. So what do I do to get that as a common denominator. I am going to be multiplying top and bottom of this one by the one it does not have, which is this one here. So by x minus 3, x minus 3, okay? So let me just write this out. I am going to have x minus 3 times x plus 1, and I'll do that math here in a second. On the other side, I have the x plus 3, x minus 3. I need another x plus 3. So I'm going to multiply, and there's a minus here that I want to pay attention to. So I'm going to multiply by an x plus 3 because I only have 1, but I needed 2, and the bottom by an x plus 3. So that's going to be a negative 2 times x plus 3. Okay, so now I'm going to do this math. So when I'm looking at this piece here, x minus 3 times x plus 1, that's going to become an x squared minus 2x minus 3. Then when I am looking at the next part of it, this part of it, I have a negative 2 distributing, so it's going to be a negative 2x minus 6 over my denominator, which is going to be an x plus 3, x plus 3, x minus 3. Okay, so now we're going to clean up the top. So I'm going to have an x squared minus 4x minus 9. And 9 and 4, that's not going to factor to anything. So I'm going to leave that and then write my denominator, x plus 3, or x plus 3 squared times x minus 3. And that's your answer. And that's the end of this video.